So today we are going to cover some basic mathematics that are very important in microeconomics. First of all, let's define some terms and notation that we use in microeconomics. For example, one of them, the equal sign notation, this equal. Yeah. X equal to Y. Basically, X equal to Y, it doesn't mean that they are numbers. X is a numbers, Y is a numbers. They can be like two strategies. They can be two actions. Like in the case of game theory, X equal to Y, it means action X or strategy X is equal to action Y or strategy Y. That means they are both are the same. For example, A1, which is action 1, can be X1. Like A1 is equal to A2. It means action 1 is equal to action 2. Or strategy 1 is equal to strategy 2. So one of the things that we mostly use in microeconomics is game theory. So when we have in game theory this kind of equality, S1 is equal to S2, that means strategy 1 is equal to strategy 2. And the other notation that we mostly use in economics, X is equivalent, 3 line, equivalent to Y. X is equivalent. This is equivalent sign. So mostly we use equivalent sign when we introduce some new concept. For example, let me tell you by example, like T equivalent to Reynolds-Tall. So it means that instead of Reynolds-Tall, we can use T. And instead of Reynolds-Tall, we can use T. It means T is equivalent to Reynolds-Tall. So Reynolds-Tall is a new concept, for example. And we just summarize this one or as a notation or as a shortcut by what? By T. For example, in coin, in tossing, instead of head, we write down H. It means H is equivalent to head. And also instead of tail, we just write down T. It means T is equivalent to tail side of the coin. So this is the equivalent sign. The next sign or the next notation that we use in economics is this one. I from 1 to n. The summation sign is the finite sum of xi, which I start from 1 and end up to n is equal to the sum of x from 1 to up to xn. Up to xn. This is the summation sign. And also we have this sign, pi, big pi, which is from I from 1 to n, for example, Si. Or again, Xi or Yi. Then this sign means cross product or multiplication. It means S1 multiplied by S2 to the n by Sn. This is called cross product. So this cross product, which is Si, I from 1 to n is equal to S1 multiplied by S2 up to Sn. The next sign or the next notation that we use here is this one. This sign means for all or for every. For all or for every. Like when we say for every x and y, nx, or this sign. This sign means there exist. This sign means there exist. Let me provide an example that we use both of them. For example, for every student there exists a chair. For every student, there exists a chair. So in terms of notation, we just can write down this one. For every student, there exists a chair. For every student, there exists a chair. Or, for example, another example, for every chair, there exists a student. For every chair, there exists a student. So here, you can write down for every chair, there exists a student. So what is the difference between this statement and this statement? For every student, there exists a chair. For every chair, there exists a student. For every chair, there exists a student. Are they the same? Different?
No.
Okay. How?
Because in the first cases, maybe some chair, no student.
Mm-hmm. Okay.
And for the last one, maybe for some student.
It means that here, maybe the number of chair is larger than the number of students. For every student, there exists a chair.
Doesn't mean they're equal.
Yeah.
Larger
That means
or equal.
larger or equal. So the number of chair can be or equal, can be more than the number of students. But here, for every chair, there exists a student. For example, there's 6 chairs. For every chair, each of chair, already there is a student. So maybe there are some student outside of the classroom that they want to enter, but the chair is not exist. So here, the number of students can be higher or equal to the number of chair. So this too, for all or for every, this one is there exists. Another notation that we use is this one. There exists not. There exists not. Another notation that we use, this one. This one means there exists a unique. For example, when we say there exists a unique solution. There exists a unique solution for our x, the sign. There exists a unique. There exists a unique solution. There exists a unique number. There exists a unique set. There exists a unique strategy. But this one means there exists a unique. This sign, it's a like vertical line. It means such that mostly in set theory we use this sign. So when we come to set theory, we will use more of these things. Yeah. And also we have another notation, which is this one. What is this one?
Member.
It's a member. Or we can say n. We can say belong to. This one, it's not a member. or not belong to, not in, not belong to. Okay, then what is this sign?
That's well,
3 dot by this way. 1 dot, 2 dot, 3 dot. It means because.
really?
This 3 dot by this way, it means because. And this 3 dot,
Next time.
this sign, this one, this notation, it means therefore.
Yeah. So
Because, therefore. And also there's another notation. This one. It means by way of contradiction or contradiction. Contradiction or by way of contradiction. This sign.